Swayam Prabha. Digital India. Educated India.
And if that is not possible, then in our next module, what we are going to discuss is basically how to correct externalities by designing incentives. Okay, this bargaining solution is not possible all the times. So we need to design certain incentives. Why incentive is required? Again, going back to the principles of economics, if you recall, one of our 10 principles were rational people respond to incentives. Okay, rational individuals respond to incentives. What is incentive? Incentive is not always with a positive connotation. That means incentive is not always some award or reward or prize or anything. Incentive can also be a punishment. So we will discuss different types of incentives in this module for correcting externalities. The first incentive what we are going to discuss is price rationing. That means we will discuss emission taxes or subsidies for better clean production or R&D, clean R&D. So we'll discuss about emission tax, which was suggested by the British economist Piguvian taxation. Then we'll also discuss about subsidies, which are actually price rationing. So that means we are imposing some price, either in the form of tax or in the form of subsidies. Then we'll discuss about the limitations of these price rationing, particularly in the context when there is uncertainty. So another mechanism by which also economists they suggested to correct externalities is quantity rationing. And quantity rationing is basically by tradable pollution permit. So instead of imposing emission tax on the polluter, what this quantity rationing suggests, they say that you assign certain uh, tradable permits to the polluter and ask them to trade. That means if somebody is very good in very efficient in production, less pollution making, then that particular firm will have extra permits with him or her, and that extra permit the firm can trade with the other firms which are actually inefficient in their production. Okay, inefficient in their production. So this tradable pollution permit is just the opposite of it is an alternative to price rationing. It is called quantity rationing. So we'll first discuss price rationing, next we'll discuss about quantity rationing. Then we'll discuss about incentive compatibility. Incentive compatibility. See, when we talk about incentive, we are talking about either subsidies or tax, and that is based on the cost of pollution, cost of abatement. If I ask a firm what is your cost of abatement, every firm would tell that cost of abatement is very high, because if they say it is very low, then the policymaker is going to impose more and more regulation. They will say then you should abate more. So they will report their cost of abatement is very high, in the expecting that if they say it is very high, regulator will ask only to control less amount of pollution. Then the regulator, that means, should design something so that the private players they will automatically reveal their true cost of pollution or true cost of abatement. So that means the regulator should design the incentives which are compatible to the private information. Private player knows better than the regulator what is the actual cost of production and what is the cost of abatement. But they don't reveal that true information. So policymakers' challenge is then to design the incentives in such a way that they will reveal their true cost of production and true cost of abatement. So that is called incentive compatibility. Once we discuss incentive compatibility, then we'll discuss about evaluation criteria of these two mechanisms. We have discussed price rationing, we have also discussed quantity rationing, emission tax vis-a-vis tradable pollution permit. But then, before imposing a policy, before implementing the tax or subsidies or tradable pollution permit, what we need to discuss is basically their effectiveness. How effective these emission tax or subsidies or tradable pollution permit would be, and how efficient they are, and how equitable they are. That means what would be the implication of these policies on equity perspective. Okay, whether they are effective, that means whether the policies that we are going to implement, whether they are able to achieve its target, whether it is efficient, that means whether they are achieving their target at a minimum cost, and then equity, that means it should not favor certain section of our society and it should not punish severely to certain section of our society. That also we need to discuss. Then only the policymaker will be in a position to take appropriate policies. And lastly, we will discuss about the problems of this emission taxation as well as the permit system, problems of price rationing as well as quantity rationing. Okay, this is going to be our module 6, where we are going to talk about incentive design based on one of the principles of economics, which says rational people respond to incentives. Then in module 7, what we said, that once a regulation is imposed, that may hamper the performance of the productive units. Then a natural question comes to our mind, then how do we actually measure their performance? And one such way is environmental efficiency. That means we assume that once regulation is imposed, that may enhance the environmental efficiency of the productive units. So here, interestingly, we will discuss about the most recent approach, which is called frontier approach of measuring efficiency, particularly the environmental efficiency, and how, what is the impact of regulation on firms' efficiency. Is it efficiency enhancing or efficiency dampening? So we'll introduce measuring efficiency, then we'll also understand measurement of environmental efficiency, and then cost of pollution control. That means, as we discussed earlier, why the private players, they are not so much interested in pollution control, because there is a cost involved, and that cost should not be so high so that it makes the productive units less competitive. Because if it is too high, then what will happen? The producers also will try to bypass a part of that cost to the customers, to the consumers. Think logically. If an emission tax is imposed on a polluting firm, then what will happen? Cost of production will immediately increase. If the cost of production increases, obviously the price of the good will increase. So that means producer will try to bypass the tax burden, a part of the tax burden on the consumers, and we have to suffer. That is why before implementing the regulation, we need to think what is going to be its impact on the cost side, cost of pollution control, because producers will definitely bypass some part of that cost of pollution control to the consumer, to us. How much they will bypass, that actually depends on the elasticity of demand. That means relative bargaining power of the producer and the consumer. If the consumers are less elastic or inelastic demand, that means they have less bargaining power, producer will bypass a significant portion of that cost of pollution to the customer. If the customers are highly elastic, that means they have more bargaining power, then producer, they themselves have to bear the cost. And it may so happen that because of this imposition of tax, the production becomes so less profitable, they may even exit the market. So that's why understanding cost of pollution control is very important. But then how do you measure that? This frontier approach, which we will discuss in this module, that will make you understand how to measure efficiency of production, how to measure environmental efficiency, and then how to measure cost of pollution control. And this cost of pollution control, once you estimate, that will guide the policymakers whether that amount of tax should be imposed or not. Or if not tax, what should be the appropriate policies? Okay, what should be the appropriate policies? And in this context, we will also discuss about these are all price rationing, quantity rationing, cost of pollution control related to price or quantity rationing. See, these are all basically, when you, if you think, these are all called formal regulation. That means formally we are imposing taxes, emission taxes. Now, in the context of developing countries, implementing these cost of pollution, implementing this formal regulation is very difficult, because that requires high level of monitoring. I am imposing tax, but then policymaker has to ensure that they have a mechanism to monitor who is abiding the pollution control norm and who is not, right? Who is emitting how much pollution, based on which only we can impose tax. So monitoring is actually an issue in the context of developing countries where we have less resource. Okay, when there are huge number of polluters, monitoring all these polluters, who is generating how much pollution, and then imposing tax is very difficult. So that means formal regulation, they have less success stories in the context of developing countries. When the formal regulation fails, then informal type of regulation becomes more and more important in this context. And one such important type of informal regulation is information disclosure. What is that? That means we will disclose the environmental performance of productive units to the public. That becomes very useful, because nowadays corporate side also become more and more interested towards corporate social responsibility, CSR. Okay, and in the era of CSR activities, once this information about their environmental performance is disclosed in public, that will create some kind of image for these private business players. If they are able to create a green image, then they get the benefit also from that through the feedback what capital market gives. That means customers, they value the product, even the shares of those companies which are environmentally responsible. So therefore, once we complete the discussion of formal regulation, we will also discuss about this type of informal regulation in the form of information disclosure and corporate, in the context of corporate social responsibility. Then in module 8, what we are going to discuss is theory and methods of environmental valuation. Now, why do you require environmental valuation? Or rather, we'll say that economic valuation of environmental goods and services. Once again, if you recall, we said that the main reason for environmental degradation is they are not properly valued because there is no direct market. In absence of direct market for these environmental goods and services, generally what we assume that these goods and services are free. There is no price. So, if we think that environmental goods and services are free, what will happen? We will generally tend to overconsume those, and that will lead to environmental degradation. Therefore, we need to have a proper price signaling for these goods and services when there is no market. So, our challenge is then how to create a market, how to create an artificial market for these goods and services through which we can actually estimate the value of environmental goods and services. That is why economic valuation of goods and environmental goods and services become so important. So we will first try to understand what exactly is the meaning of economic value of environment. Then there are different approaches to estimate the value. One approach is called stated preference approach. That means we will create hypothetical market and then we will ask the respondents to state their value. For example, let us say that we have a forest and we don't know what is the value of this forest. Should we preserve the forest as it is, or should we deplete, should we cut all these trees and make this forest area useful for some infrastructure building? And as we said that as an economist, we are not environmentalist. We will not go by sentiment that trees are always good, we should preserve that. Rather, throughout this course, we will follow the neoclassical paradigm of utility maximization, where our idea is whether tree is good or bad, forest is good or bad, let the respondents, the stakeholders, they state their value towards this. That is the approach. So, in stated preference approach, we will learn how to create that type of hypothetical market and estimate the value of environmental goods and services through this approach. Basically, two approaches: contingent valuation method and choice experiment. These are the two approaches we are going to learn in stated preference approach. Then there is another approach called revealed preference, where customers, they have respondents or individuals, they have already revealed their preferences for environment. How is that possible? We said that environment does not have any direct market. Then how is it possible for the respondents to reveal their preference? Yes, it is possible. They reveal their preference for environmental goods and services through a market which is related to environment. For example, we can think of housing market. Same type of house, if you take the price of that in a most environment friendly area and in a polluted area, then you will see that price of the same type of house in an environment friendly area is much higher than the other one. That means respondents, they are ready to pay a premium for better environment because other things are same 2 BHK, same square feet, same sellable area, same two window or one window, same thing. All other features of that house is same, only environmental quality is different. And as a result of which there is a difference in the price. And that price is basically the premium that the respondents are giving for the environmental quality. That is called reveal preference approach. Okay, in this reveal preference approach, we will discuss about travel cost method and hedonic price theory. And lastly, we'll discuss about production function approach, where environmental goods and services will enter as an input in the production function. We'll estimate the production function and then we'll see what is the value of environmental goods and services. So in all these approaches, our objective is only to get a proper price for these environmental goods and services. So up to now, that means up to module 8, what we have discussed is actually 50% of the course. In the course title, what I said, environmental and resource economics. So that means you can say up to module 8, this is all about environmental economics mostly. Then in module 9, we are going to discuss only optimal extraction of renewable and non-renewable resources. Then you might be thinking, we have discussed so many modules for 50%, and this module, there just one module for another 50%. Why this is so? Yes, this is so because here we are going to talk about optimal extraction of renewable and non-renewable resources. And when you talk about optimal extraction, what does it mean? That means we should not extract the resources too rapidly or too slowly. Okay, too rapidly or too slowly. But how do you ensure then optimal extraction? That require this is a typical problem of utility maximization in a dynamic setup. That means suppose we have certain barrels of oil. How many barrels of oil, that we don't know. Let's say 100 barrels of oil. And that we are going to use for the next 10, 15, 20 or 50 years. That means here our objective is to decide optimal extraction. That means optimal extraction at each time period, not only a single period. That will give so that the sum of the utilities is actually maximum. So it is not a static framework, it is a dynamic setup. Okay, it is a dynamic setup which requires dynamic optimization or dynamic programming. Now this dynamic optimization, control theory or dynamic programming, we have not yet learned. In this course only, I will introduce the dynamic programming in a very lucid manner so that you can understand how to maximize utility in a intertemporal framework. That means this is not a one-shot game where I have some amount of resource what we are going to use now itself. I have a resource that we are going to use for the remaining 10, 15, 20 years. Okay, and how will you ensure how much liter of oil to extract in period 1, period 2, period 3, like that in tth period? Okay, so that means we need to determine a price path, because as I said, price will only tell you how much to extract, how much to sell. Since this is a price we need to determine for each and every period, it is not P, rather it is PT. P at a particular time period. That is why it is called a price path. Optimal price path that will lead to optimal extraction path. And that would be discussed, that we will understand by dynamic optimization or dynamic programming. So you will get a training of dynamic programming also in this course. That is why this one module itself is remaining 50%. So this is going to be our entire syllabus, what we are going to discuss one by one. We will follow the textbook, and textbook, let me write it down. The textbook for this, the title is Environmental Economics in Theory and practice by Nick Hanley, Sogren and White. This is the textbook. Apart from this textbook, we will be using several journal articles, and those journal articles, references for those articles, I will be referring from time to time as and when it is required. Okay, this is going to be your textbook. So you can try getting a soft copy of this book. Okay, Hanley, Sogren and White, Environmental Economics in Theory and Practice, and journal articles. I will give you the link. You can easily download that. With this, we are closing our discussion today, and tomorrow we will discuss about our module number 3, where we are going to discuss the impact of economic growth on environment by the EKC approach. So next class we will discuss about environmental Kuznets curve. Thank you.